All right, everybody, we are going to make box plots next, and I'm actually going to make the box plot slide in the middle of this video. So hopefully that won't take too long, but making box plots is super easy. It's very similar to the histogram in that it's a Seaborn function. So you go SB dot box plot parentheses, and then you put the name of the variable. So I'm going to do I'm actually going to do diagnosis age first, and so df square bracket diagnosis age. And so when I just do that, the default is it makes a vertical box plot. And when I'm looking at side by side box plots, which we'll do some of, it's great to have it vertical. But for my eye, I prefer it horizontal. And so that's just another parameter that you put in there. So I'll put that in. So orient. So the orientation. So orient equals, and I would like it to be horizontal. And so I'm going to go quote H to let the Python Seaborn package know that I want the orientation to be horizontal. And so when I do that, bam, it's horizontal. And what we can see here is that just like any good box plot, the median is in the middle. And for the diagnosis age, excuse me, for the diagnosis age variable, the median or the 50th percentile is 11. And so the middle of that box is right here at 11. The first quartile is 5. The third quartile at the end of the box is, what is that, about 18? Let's see what it really is according to this. Yep, 5 for the first quartile, 18 for the third quartile, or the 75th percentile. And then the end of the whiskers should be at the min and the max, unless there are outliers. So here at the min of 0 and the max is 32, there aren't any outliers. If you look at 1.5 times the width of this box, it goes beyond the 32, the maximum data point in the data set on the variable. And so there's no outliers. So it's just the whisker goes to the very largest value, and down here the whisker goes to the 0, the smallest value. All right, we're going to do that exact same thing, but with our sibling number. And so get another code block and do that with sibling number. And I'll just start it already with the horizontal orientation. So there we go. So this has a bunch of outliers. And the reason it has so many outliers is the middle half of the data between the first quartile and the third quartile, that's half of the data in this data set, are all between these numbers that are super close to each other. So, what are they? The first quartile is 1. The third quartile is 4. The interquartile range is only 3. The IQR is only 3. 1.5 times 3 is 4.5. If I add 4.5 to 4, I get 8.5. And so when I look over here, all of these dots are past 8.5. The whisker ends at the last data point before 8.5, which is in this case 7. So that's over here. Oh no, it's ending at 8.5, it looks like. Okay, I must have a data value at 8.5. I don't know. I don't see the data values. I just see the percentiles here. Or there must be an 8 there. It can't have 8.5 siblings. So there must be an 8 there as the last data value before you get past the 1.5 times the IQR and get all these outliers. Okay, I'm at 4.5 minutes, so I'm not going to show you me making the slide. But I'm just going to make a screenshot of the two box plots and then put the code on the side. All right, have a great day, and I'll see you in class.